Imagine code that's easy to change, reuse, and understand. Introducing S.O.L.I.D, the principles that make it a reality. S.O.L.I.D stands for 5 interconnected principles that guide object-oriented design. The purpose of S.O.L.I.D is to create code that is maintainable, flexible, and reusable. So let's start with the first principle, single responsibility principle. The core concept of single responsibility principle is a class should have one and only one reason to change. The benefits of applying single responsibility principle are as follows. It promotes modularity and cohesion, it reduces coupling and complexity, and it improves testability and reusability. To understand the full benefits of single responsibility, we'll jump into the explanation of modularity, cohesion, coupling, testability, and reusability. So, modularity and cohesion. Modularity is about breaking down code into smaller, self-contained units, classes, or modules with specific responsibilities. This makes the code more organized and easier to navigate. For example, in a good code, journal entry repository, journal entry notifier, and journal entry formatter are separate modules, each managing a distinct responsibility. Cohesion ensures that elements within a class or a module are tightly related to each other and work together towards a single purpose. This makes the code more focused and understandable. For example, methods within each class are cohesive as they all deal with a specific aspect of journal entry management. Coupling is about reducing dependencies between classes, making them less intertwined and more independent. This means changes in one class are less likely to affect others. In bad code, tight coupling between database notification and formatting logic makes changes more risky and harder to manage. Complexity is about making the code more easier to understand, maintain, and modify. Testability is about smaller, focused classes with clearer responsibilities that are easier to test in isolation. We can create unit tests for each class without worrying about complex interactions with the other parts of the system. For example, we can test journal entries repository database operations without involving email notifications or formatting. Reusability is all about classes having a single responsibility, where these classes can be more easily reused in different parts of the application, or even in other projects. For example, the journal entry formatter class could be used to format journal entries for both printing and web display. Let's take a look at this example to illustrate the previous slides. So let's consider a class called user manager with these responsibilities: storing user data in a database, validating user input, sending email notifications. This class has multiple responsibilities: database interaction, email notifications, checking email validity. It's also very tightly coupled with other things in the code, where changes in one area can affect others. Also, it's harder to test and reuse the individual components of this class. This is the refactored version of the previous code, where we separated the responsibilities, where the user manager class is split into a user repository which handles data storage, a user validator class which only cares about validation of the user's input. We created email sender class which is only concerned about sending email notifications. We created the user service class which orchestrates the user creation logic. Also, the classes became very cohesive, where each class now has a single, well-defined responsibility. Also, we managed to reduce the coupling between classes, where the classes now are less dependent on each other, making changes much more easier. Also, we improved the testability, where each class can now be tested independently, and we enhanced the code readability, where the code now is much more organized and easier to understand. These are some additional useful tips. Reason to change. Always focus on the reason for a change, not just the number of methods. Try to make everything cohesive, where you should ensure that methods within a certain class are tightly related to its core responsibility. Also try to be granular, where you should balance having too many small classes with having overly large classes. And also do refactoring. Don't be afraid to restructure code to better align with single responsibility principle. With the single responsibility principle as our guide, we are crafting laser focused code, each class devoted to a single distinct purpose. In the next video, we'll delve into the second principle, which is the open close principle, which will empower us to craft code that welcomes changes with open arms, extending its functionality without altering its core structure. Thank you guys, and thank you for your attention.